Yeah, can you see my screen?
Yes, we can.
Okay.
Thanks. Go ahead.
Yeah, so I will be talking about optical transients and part of the big data in context of Indian Astronomy Program. In fact, there will be another presentation by Yogesh later on, who will be covering more about big data in context of Indian astronomy. There are many participating institutes, as you can see from the very first slide, the number of logos there. There are many participants here, as you can see, and it basically cut across most of the Indian astronomy institutes who are participating in this BRICS ITDN program. And that's thanks to David that he has been sort of talking to us and pursuing for a participation in this program. Let me start with the legacy of systematic optical transient observations in India. Of course, the transients are always there in the sky and people have been looking at that. But the very early records in India, in fact, exist from very old Madras observatory in 1786, where the sun and solar system objects were recorded in late 18th century. Of course, coming back to the more recent time now, the most of the Indian programs in the 20th century were about variable stars, novae, lunar occultations, and related to that. And now the modern day, most of the optical observations now are done with, so far done with 1 to 2 meter class optical telescopes. And those telescopes have played very important role in observations of early GRB afterglows, for instance, as well as later on in the monitoring of supernova. That's a more about spectroscopy monitoring as well as the imaging monitoring of supernova. There is interest about X-ray binaries, active stars, and AGN variability. Of course, this interest has grown up with the participation in many big telescope projects, many other international projects, and now there is interest about the EM counterparts of gravitational wave sources, many different types of transients, including the reverberation mapping, low luminosity AGNs, blazar, X-ray sources, pulsar, and also there is interest about fast variability. So the millisecond imaging in optical telescope, tidal disruption events, and the UV transients. And that all basically comes from because there are many telescopes available for observations in the country. And it's not surprising that a large fraction of astronomy, astrophysics research output from India comes from these areas, basically the transient areas. And as you know that some of the research is already being carried out in collaboration with astronomers in the BRICS countries. There are bilateral and multilateral aspects of those programs. Now, India, we believe that India has been fortunate to have very generous funding from its funding agencies, and it basically represents some of the major facilities across the world also, and particularly in the the longitudinal range where India continent is. So there are telescopes starting from the radio, of course, the GMRT, and there is a lot of many international astronomers use this facility. And now 3.6 meter Devastal optical telescope, which has just come up and is ready for observation. And the AstroSat, the satellite, which has the UV facility as well as the X-ray observations. And more recently about the gamma ray astronomy also, there is a telescope which is coming up, MACE, in Ladakh. So you can see the purpose of this slide is that some of the major facilities India is fortunate to have it in the same, land, and that helps when we talk about the transient observations. It's quite important that the same sky is seen from, these telescopes in different wavebands. If we talk particularly about the optical eyes, we are having several telescopes starting from 1 meter class to now 4 meter class telescope. And they are actually distributed right from the north to the south region in the country. There are a couple of major upcoming facilities. There are not many, but somewhat quite important for the transient program I would like to highlight. that we are ready with a 4-meter international liquid mirror telescope. That's a concept of the mercury-based liquid mercury forms the mirror, and that is ready, but it has not seen the first light. And in the next season, which is going to start few weeks from now, next observing season, here after the monsoon period is over, this telescope is very likely going to see the first light. And this is a 4-meter liquid mirror telescope. There is another telescope which will come up soon, which is a 2.5-meter optical telescope at Mount Abu. And there is a recent interest from our space agency, which is ISRO, who wants to install 0.5 to 1 meter class optical telescope for space situational awareness programs. And so many of the institutes participating in this BRICS program are likely to going to get one of these telescope. And if you see about the space facilities, there is the Aditya L1 facility. In fact, I'm also including solar, because sun is also a transient, and there are many astronomers in India who work on solar facilities, particularly about the data handling now with the upcoming facility. So Aditya L1 is one facility which is going to come up, and another facility which is likely going to come up is INSIST, which is the Indian Spectroscopic and Imaging Space Telescope. It is led by Indian Institute of Astrophysics, and that will be a UV optical observing facility. So both of these are space-based, modern facilities. Of course, India is also participating in TMT projects. A lot of development work related to the telescope and all related software as well as the hardware is being carried out in India also. And of course, the square kilometer array, which is in the radio thing, and I guess Yogesh will be talking more about that. And not to forget that when we talk about transients, the hot field is nowadays the gravitational wave detection, and India is also going to have a LIGO consortium, one arm of the LIGO consortium for the gravitational wave detection. So the aim of these slides was to basically tell that there are different facilities in different wave bands in India, and particularly about optical telescope. When we talk about transient, observations, it is important to have a very continuous longitudinal coverage, so that all important sources, can be observed without a gap. And if you look at the 4-meter class telescopes distribution across this side of the globe, there is a large gap between Australia and Russia and the European telescope. Of course, now that gap is very nicely filled by Devastal 3.6-meter Indian telescope. Devastal is an Indian telescope, but Belgium also has a contribution to it, and they have a time-sharing agreement on this telescope. So we can see that with these 4-meter class, and of course larger telescopes here, including the 6-meter Russian and the 10-meter SALT, as David pointed out, that this actually nicely covers a very good longitudinal coverage, both in the northern hemisphere as well as in southern hemisphere, and which gets very important aspect for any detailed follow-up observation of transients. If you talk about key science areas of interest in the Indian context, there is a lot of interest about EM counterparts of gravitational wave sources. I'm sure this is a very hot field, and every country, every telescope wants to look at that. And the GRB supernova science, there is a large group of people in India who do this kind of work. Then there is a growing group on intermediate mass black hole, which is quite important now, right from the a very high mass black hole to now intermediate mass black hole through reverberation mapping and the variability. There is interest about blazar, quasars, and other types of Asian variabilities, including intraday variability, intranight variability. Then this interest about, which is one of the oldest interest from Indian astronomers, about stellar variability and cataclysmic novae kind of variables. UV transients from planetary collisions, and these TD events and the intermediate mass black hole related. There has been theoretical investigations on that from the country, and people are interested in looking into this from UV telescopes. Gravitational lensing is also one of the area which is coming up in collaboration with, particularly with Belgian astronomer. And I'm including here also as a transient because of its cosmological importance, time delay measurements and all that. Of course, solar physics to be also included in this category of transients, and the planetary occultation. In fact, there is a large follow-up of different kinds of stars for the planetary occultation, satellite debris tracking, which is basically stemming from our space agency's interest, and the exoplanets also. So this is a very broad area, of course, and there are many astronomers in different institutes. We have about half a dozen institutes where people are working on that. So what are the areas where Indian transient programs under BRICS ITDN, which we can consider as a niche area? So we can actually provide a trigger also, the trigger based on dedicated survey telescope in Indian longitude. In the next slide, I will basically talk about this, particularly the importance of the liquid mirror telescope, which is coming up, which can actually provide many triggers on transients. Then, of course, the optical NIR and radio follow-up, which is being done presently in most of the cases, and there has been several papers in high-impact journals, particularly in Nature and Science, where the optical and radio follow-up from Indian telescope, particularly 2-meter Himalayan Chandra telescope and 3.6-meter DOT now, and the GMRT. So all these three telescopes are going to play a major role in transient programs. Science and training of human resources, this has already been pointed out very nicely by Carolina, and that is something our funding agencies also support it very strongly, that whatever we are doing, there should be a component about the human resource development, particularly PhD students, as well as going to the public and explaining them about these research areas. And of course, there is a talk about networking of observatories as well as sharing of computing facilities. So these are high-speed computational, things. And here comes the engineering aspect and participation from Indian industries and experts. So different institutes at different levels have been engaged with Indian industries and experts to basically develop this kind of high-speed computing, as well as different kinds of software, schedulers, and view-related, the virtual observatory-related, programs. Of course, we do see, and it has already been pointed out, that synergy with space astronomy programs. So particularly Indian space astronomy, which is very vibrant presently and very supportive for astronomy, and a mega science program, but for the big data management, and AI and ML for source identification. So I will, yes, so before going to the next slide, this Indian telescope possible data products, we already know about that, but I just want to highlight it here, that what we can get actually in the transient program. And one of the important thing is the deep radio continuum imaging, particularly after the GMRT has been upgraded with a wideband receiver. We can really opt in deep radio continuum imaging in very short integration, as well as the spectroscopy capability on GMRT. And high energy band follow-up with AstroSat and whatever is the upcoming space facility, as I said, the UV and the optical facility, the upcoming space facility. And the fanned transient triggers from 4-meter ILMT. And then optical spectroscopy data for follow-up programs. One of the things which I would like to highlight here is this polarimetry, in fact. The astronomers in India have been discussing about this. And in fact, we regularly use the polarimetry mode, whatever is available on our telescope. But we want to see the way forward that we want to equip the telescope, and particularly the 3.6-meter telescope, with a full-fledged spectropolarimetry capability. And I believe that transient observations will greatly benefit by that. And so the observations in polarimeter mode is also one of the possible data product which can come from Indian telescopes. And not to forget is the geographical longitudinal advantage with low latitude optical radio facilities that helps in covering large sky at both the hemispheres. Now,
Amitesh, can you try to wrap it up in the next minute or two?
Yes, sure. So this is just to highlight the 4-meter ILMT telescope, which is going to be very interesting for transients. this is a 100-second exposure every night of half-degree transiting sky will be obtained, and at least for 5 years. And so you can immediately see that because of 4-meter ILMT nature, we can go very faint, and the calculations are that we can go up to 23 magnitude detections, particularly for supernova 1A, we can actually cover the redshift of up to 0.7. And so this telescope is going to be very interesting. And in fact, there is a summary here that ILMT is going to, from the past survey, it stands out, in fact, in terms of the coverage as well as the cadence, that is going to provide a very good data on the transients. Now, this is my last slide. This is the synergy area for big data management of ITDN. Of course, details will be covered in the next talk. One thing is the 4-meter ILMT survey plans to explore AI and ML, particularly for applications for transient detection. And there has been there was a workshop about a few weeks ago, and we have discussed about this in detail, and that we want to go with the AI and ML. In the synergy with the Aditya L1 Solar Telescope, there is a plan to establish modern data center and archiving center, which can be common to not just the space telescopes, but also the Indian other observatories. And not to forget is the participation in the space situational awareness program, because they wish to install many half-meter and 1-meter telescope, and we can simply piggyback on their network for mutual benefit. So these telescopes can be made available to the astronomers in a time-sharing basis. And of course, GMRT and ESCA being, the largest data handling requirements in astronomy, hence a natural synergy with the radio, comes up here. So I thank David and the organizers of this committee to invite me for giving this presentation. And my discussion with all these stakeholders from the Indian side has been that we will welcome collaborations and cooperations from BRICS participants in this ITDN program. Thank you.
Thanks very much, Amitesh. That was really interesting. And there's obviously many synergies that you pointed out, and yeah, that's great. So I think we should proceed to the next speaker, Luis da Costa, who'll be speaking about Brazil and the LSST.